determined that there are actually 7 Earth-sized planets orbiting the nearby TRAPPIST-1 star about 40 light years away. What's more, as you can see in this illustration, is that 3 of these planets, marked in green, are in the habitable zone, where liquid water can pool on the surface. In fact, with the right atmospheric conditions, there could be water on any of these planets. So for the first time, we found as many terrestrial planets around a single star, and that's the first time we have been able to the masses and the radii of these habitable zone type Earth-sized planets. These planets are among the best of all the planets we know to follow up, to see, for example, with the James Webb Space Telescope that we're going to launch last year, the atmospheres, and also to look at biosignatures if there are any. The discovery gives us a hint that finding a second Earth is not just a matter of if, but when.
As Thomas mentioned, we used a Spitzer space telescope with over ground-based telescope to discover 1, not 2, but 7 Earth-sized planets. And this is the first time that so many Earth-sized planets are found around the same star. Furthermore, with 3 of them in the habitable zone. And the star itself is what is called an ultra-cool dwarf, which is the least massive kind of stars that exist. And these stars are much smaller, much cooler than our Sun. And still, they are very frequent at the scale of our galaxy, more frequent than solar-type stars.
So Spitzer was launched in 2003, and it was never intended to study exoplanets. So we had to do some clever re-engineering while it's in space still, and it's more than an astronomical unit away from the Earth, so you can't fly out and do anything about it. But we did clever engineering on the ground to allow Spitzer to measure star brightnesses very precisely, 1,000 times more precisely than we had imagined Spitzer would be able to do. And then what we're going to show in the next animation is how planets, very similar to the way the Kepler Space Telescope does it. We don't image the individual planets. What we do is the planets pass in front of the star. We see the amount of light that the star is dimmed by when that planet is blocking it. So the dips you see in this animation are the planets going in front of the star, blocking a little bit of the light. The size of the dip tells you the size of the planet, so we can get the size of the planet directly from measuring the dip. Now, when you see the different planets, they keep orbiting around, and every time they transit, you can measure the spacing between the transits, and that tells you about the orbit, the period of the orbit, how long that year is, and for that planet. And then when we know how long it takes for the planet to go around the star, we also know the distance it is from the star, and it also tells us whether or not it's in the habitable zone.
We're currently using the Hubble Space Telescope to study the planets in the TRAPPIST-1 system to determine if they have hydrogen-helium-dominated atmospheres. It's actually great to find out if they don't. That gives us another push forward in having these planets be, in fact, rocky, and also the potential of those planets to support water on their surfaces. Just last year, Hubble actually probed the innermost planets of the TRAPPIST-1 system, TRAPPIST B and C, and found that they didn't have hydrogen-helium-dominated atmospheres. So that's just one more step along the path to having these potentially habitable worlds.
So with the James Webb, we'll be able to study the atmospheres, and we will try to assess the greenhouse gas content, which will help us understand the surface temperature of the planets. Are they indeed the right temperature to support liquid water and life as we know it? In fact, we're even going to use the James Webb to search for gases that don't belong, that might be produced by life, such as oxygen, ozone, methane, and a whole host of other gases.
There's many things we don't know, many questions we have that come up when we see these observations. We look at all these animations. Very likely, nature is way more beautiful, way more amazing than what we've animated here. It's always that way. And so for us, the question is, how do we actually open up our lens and see these things? How do we get so much data from that the kind of questions that Sarah asked are actually able to be answered? And for me, at the end, it's all about that thought that I have so often when I go to bed at night and really imagine how these other worlds really look like. The fact that there are worlds out there, just like the Earth, that have some commonalities with the Earth, and you could imagine these worlds. It's just only happening right now. These questions about are we alone are being answered as we speak in this decade and the next decades. So I'm really excited about this.
Thanks, Thomas. With that, let's transition to Q&A. We've got a ton of questions on social media, so we'll go there first. If you'd like to ask a question using social media, please use the hashtag AskNASA.
All right, wonderful. We've got lots of questions coming in. This first one comes from Twitter user JJams, who asks, what is the total amount of possibly habitable planets we have found, including these TRAPPIST discoveries?
Okay, I'll take that one. Okay, the total number of habitable planets, believe it or not, is unknown. And it depends on who you ask and how you count them. We would say that there are, let's say, a few dozen exoplanets that you might consider habitable, but the bottom line is that many of them may be a bit too hot or a bit too big. We really have to wait until we can see the atmospheres to know how hot or cold the planets really are. And that's why the TRAPPIST planets are so relevant, because they actually, unlike a lot of the other habitable zone planets, we can actually assess them in the near future.
Wonderful. All right, the next question here comes from Scott, who asks, any confirmation of water on the planetary bodies?
Yeah, I can handle that one. There's has not been any confirmation of water on these planetary bodies, and it'll take a lot of observations with Hubble or in the future with Webb to probe the atmospheres and see if we can detect water on these planets.
But I'll just back up one step, though, and answer a slightly different question, because if we want to think about an intelligent civilization elsewhere looking back at us, they may be having a press conference saying, hey, there's 3 habitable planets there. Venus, Earth, and Mars may appear to be in the habitable zone no matter how we describe it. So let's wait and see what's out there.
Starting with Hubble and then moving into JWST to continue the exploration of these atmospheres, we could see results, in the early 2020s.
And thank you. And I know this is the first time 7 Earth-sized planets have appeared around a star like this. What is the closest runner-up to that? How many Earth-sized planets around a star that you've seen prior?
I think it's a 2 or 3.
Yeah.
No more, found by Kepler.
And which star is that?
Oh, I don't remember. There are so many Kepler planets.
Okay, thank you.
The good news is there's a lot of work that's being done on kind of the first 5 to 10 of those miracles that are being looked at, not necessarily because we have our eyes set right now on going to a star. It's a big leap, but because we're looking, for example, at the outer solar system. We want to get there a lot faster. We want to get there with more payload. We want to get there energy. And so the way this game works, it's really it's leaning forward. It's really just because it takes 100 miracles, not backing up. That's really what I would believe is what NASA is all about, and that's also what led to this kind of discovery in many ways. Spitzer itself had a whole bunch of miracles on detectors and systems, and the same is true for the other question.
All right, this next question comes from Facebook Live here. What is the distance between these 3 planets? Is it something like 500,000 kilometers? And what is the distance between E and the star?
The distance between the planets are a few times the distance between the Earth and the Moon. So we're talking about something like millions of kilometers, and not hundreds of millions of kilometers for an Earth around a Sun-like star. And for the planet F, the distance is something like 5% the distance between the Earth and the Sun. So it's much closer to its star.
Look at what's happening at Mars, where we're really looking at the complex chemistry that's happening there. Look at the recognition that Mars actually is a place where there not only used to be water, but there's water today, abundant water. In parallel to that, the recognition that we can now have the technology ability of going to Europa and actually looking at that system, which is in its own right really an exciting system, because there's an ocean world there that hits the rock at the bottom in a really unexpected place in a site. There's many other places like that. And then on the theory side, we already heard that the really understanding of the biology of life. There's a tremendous amount of progress. So together, these areas really create kind of a crescendo towards that, really answering that question that has been on our minds for so long. This is the right time to ask that question. It is the right time to have this discovery.
Thank you. I'm afraid that's all the time we have left. Please keep questions coming by sending them at the hashtag AskNASA. And for more information,
that is the NASA announcement. There's a few things that I'd like to go through. From TRAPPIST-1 is obviously an important size. Oh look, we're getting a picture of the International Space Station going around the globe. Very nice. Like I say, TRAPPIST-1 from C, D, E, F and G, F being 13 times Earth and G being Earth size, with a minimum orbit of 1 day and a maximum orbit of the planets of 20 days, 20 Earth days. That's incredible. They do point out that 2020 we might be able to get some Hubble images. Hubble could get onto this, only being 40 away now, and it might only take a year for these pictures, so they're kind of slowing things up there. I think they're waiting for the James Webb Telescope to come online in 2018. Spitzer does know. I mean, come on. Kepler star with planets was mentioned, and that is important. But what I would like to say is that NASA is looking to the outer solar system, like I said, and they're playing games, because just now the spectrographs that they're saying that the James Webb Telescope is going to do in 2018 has already been done by WISE, and I'll show you that just now. I'm just going to jump out here and we'll change the tab. So exoplanet exploration, you can go to this yourself online, and you can see here I've been searching through, but what I'm going to do is I'm going to go to the actual search. So I'll explain this to you, how this works. So we have here on the left the host star, we have the planet's letter, so we'll be able to find TRAPPIST just now. I'm just going to search for it and show you it. And the planet's mass, the light years it is from Earth, the magnitude, and the date of discovery here, which is also very important. The date of discovery, that's the last column. So we're going to go and find TRAPPIST right now. All we need to do is head up here, and there we are. So we have, excellent, we have TRAPPIST-1, we've got the search here, and we have the planet's mass is undescribed, and it was discovered in 2016. I believe this is the one that was discovered in April 2016, and is what we've been looking for. Now, WISE, they have actually asked people to go through, so I'm going to jump onto the other page here and show you how this works. So that's national television. What we're looking for is backyard world. So it's Zooniverse. You can see the project discovery at the name at the top, and just sign in as yourself. Go to class 5. And it shall go to movement of certain stars, and once you've found them, NASA are asking, what you do here is use your movement at the back. You can zoom in. I will show you a star here that moves across the frame from one to the other. You can see here, mostly this is what you'll see. When you see something moved, though, if it's moved at a specific amount, then you've found something. You've found what they're looking for. Now I'll show you here. We hit field, and you can mark anything you've seen. You can delete marks if you haven't made the right ones. In closing, I would just like to say that this is worth doing. You're worth going on here and trying to find. What we're looking for here is actually Planet 9, and that's why NASA are saying they're looking to the outer solar system. They're even asking us. We have a couple of interesting points that one of the NASA employees made, that Mars has complex chemistry and water all over it, and going to Europa is the right time to announce this announcement also. And I think it's really just to keep us distracted. I mean, we've been waiting for this, guys. We've been waiting for this announcement and the distraction, but what is it they're exactly distracting us from? That is the worry for myself, to be fair. I would like to thank you everybody for watching, guys. Let me know what you think. Hit the like button if you liked it on your way out, and subscribe. It's much appreciated.